Hello, you are welcome to this channel. This is tutorthink and I am Daniel. I'll be taking you through classification of differential equation in terms of linearity. How do you identify whether a differential equation is linear or non-linear? I have already done a previous video under this topic that talks about how to classify the differential equation into order and degree. If you haven't seen this one, go through my channel, search for the classifying differential equation into order and degree, learn how to classify these equations into order and degree, and come back and watch this video. So, when we have a differential equation given to us, for example, I have an equation here of this form, I have another differential equation here. Anytime we come across differential equations like this, and we are asked to classify them into its linearity, we must know the rules. How do we know if the equation is linear or non-linear? So what I did was that I have broken down the rules or the things that makes a differential equation non-linear. I have broken it down into 4 pieces and I have called it the 4 conditions. And if you learn this condition, or after we go over this condition, anytime you see a differential equation without these conditions, then you know that that equation is linear equation or is a linear differential equation. I repeat, there are some basic things that will let us identify whether a differential equation is linear or non-linear. And I am saying that I have broken down these conditions that make a differential equation non-linear. So if you come across a differential equation without these 4 conditions, then that equation becomes a linear equation. So I have broken it down into condition 1 to 4 and let's go through. So for the first condition, any differential equation that has y standing alone raised to the power n is a nonlinear differential equation. So y raised to the power n, where n is greater than 1, is a nonlinear differential equation. One thing you should also know about y raised to the power n in that differential equation is that the y raised to the power n must be alone. It shouldn't be multiplied by any other function. So when we look at this example here, I have dy dx equal to x plus y squared. Y squared here has the condition y raised to the power n, where n equal to 2. And the rule says that if n is greater than 1, then the equation is nonlinear. So y is standing alone, as I have written here. It must always be y raised to the power n alone. Y is standing alone, nothing has been multiplied. But as soon as the power is equal to 1, then the equation is linear. Okay, so I have another example here. Dy dx tan x minus 3xy y squared equal to 0. When you look at this one carefully, we have y raised to the power n. N is greater than 1, but however, y is not alone. We have minus 3x multiplying y raised to the power n. So this does not qualify the first condition. And so for this equation, it is a linear differential equation. So this is a linear differential equation. But however, this is non-linear because it qualifies the condition. Let's move on to condition number 2. For condition number 2, we will come across a differential equation of this form, where a first derivative is multiplying another derivative. This is the same as me having dy dx all raised to the power squared. So when we come across something like this, inside the differential equation, that equation is nonlinear. We must know that the degree must be more than 1. So if the degree is 1, it means we have only dy dx without multiplying another dy dx. And that equation is not nonlinear, but rather linear. So when 2 derivatives multiply themselves, the equation is nonlinear. The power can be more than 2, it can be 3, it can be 4, and above, as I have written here. So let's take this example. I have d square y over dx squared plus 5 dy dx all squared minus 15y equal to 0. Now I want to check if this is linear or not. So I'm looking at the conditions that will make an equation nonlinear, and I can see that this condition qualifies it to make it what? Nonlinear. So because of this, the whole function here, differential equation here, is a nonlinear differential equation. If this condition is not found in this equation, then it will make it linear. Okay, so let's move on to the third condition. In the third condition, I will also add something like y d square y dx squared and above. So for this condition, we will come across the term or the form y dy dx. It can be y dy d square y dx squared. It can be the fourth order, the fourth derivative, the third derivative, the fifth derivative. No matter the type of derivative here, the number of times this has been differentiated, no matter what it is, so far as y is multiplying the term, that particular derivative, the equation is nonlinear. I am actually trying to explain it in a way that will make you understand. So there are other ways you can learn this. So let me box on with what I have. When we look at this one too, we have y multiplying a second derivative. So this condition makes the equation nonlinear. So anytime y multiply a derivative term, the equation is nonlinear. So I have this example here, y d square y over dx squared minus 2x squared y squared equals 0. And this condition makes the equation non-linear. If the derivative term is the third derivative, fourth derivative, it still qualifies. It makes the equation non-linear. Then our final condition, this one, any differential equation that has a square root is nonlinear. When we look at this, we have a square root here, so the whole equation is nonlinear differential equation. And for this one, we have a square root here, the whole equation is a nonlinear differential equation. So these are the 4 basic rules. The first one, we have y raised to the power n, where n should be greater than 1. However, y must also stand alone. If y is raising to power n and that n is greater than 1, the y must stand alone. Nothing should multiply it. It should stand alone. It can be a subtraction or an addition, but it must not be multiplied by anything, as we have here. So this is the first condition, and we learned that for the second condition, a second derivative, a third derivative, a fourth derivative, a fifth derivative standing alone makes an equation nonlinear. And then we went on to the third condition, saying that anytime a y is multiplying a derivative term, that term is what? That differential equation is nonlinear. So we have the first derivative, the second, it can be third, fourth, and fifth, and above. And then finally, any differential equation containing a square root is nonlinear. We should also remember that for the condition 1, it must always be y raised to the power n. For instance, if we see x raised to the power n, that equation does not qualify for this condition. The condition must be y raised to the power n. So you must not forget that. The last thing I'll talk about is that apart from these 4 conditions, if you look through the differential equation without seeing any of these things, these conditions that we have spoken of, the differential equation is a linear differential equation. So we will take an example here. We said we should classify the following differential equations given the linearity of each equation. So we will look at the first one. For the first one, is it a linear equation or a nonlinear differential equation? We can see that there is a condition that we spoke about here. Y is multiplying a derivative term, and so this equation is nonlinear. And this condition is condition number 3. So here you can draw the table as I have done here. You just write non-linear differential equation. So let DE be the differential equation. Then let's move on to number 2. Number 2, we have the square y dx squared plus 6 dy dx all squared minus 15y equal to 0. Let's locate if we can find a condition. So we have a condition here, dy dx all squared. This means this derivative multiplying itself 2 times, it qualifies. It is part of the conditions that we spoke of. So this is a nonlinear differential equation. So let's go and check. This is condition number 2, as we can see here. So forget about anything that is multiplying the derivative term. We have 6 here. Just once we know that this condition is here, anything multiplying or subtracting, that's, we don't care about that. We just want to see this condition, and it qualifies it to make it nonlinear. So this is also a nonlinear. So you write nonlinear differential equation. So we move on to the third one. We have dy dx equal to x plus y squared. This is condition number 1. Y is standing alone. Y is squared. The power of y is greater than 1. So this makes the equation nonlinear differential equation. So we write a nonlinear differential equation. Then we move on to the fourth condition. The fourth question, we have 2x dy d square y over dx squared plus 4x squared dy dx minus 3y. There is no condition here. This is y, the power is 1. It is being multiplied by something, it doesn't qualify. We have x squared multiplying the derivative term, it doesn't qualify. The condition is supposed to be y squared or y cubed and above. When we look at here, there is no condition that we spoke of. So this equation, as we see, is a linear differential equation. So here I have linear differential equation. And then we move on to the fifth one. We have here tan dy dx minus 2xy squared equal to 0. Look at this critically. We can see there is a y term here. The power is greater than 1, but it is being multiplied by another term, minus 2x squared. In the rule that we studied here, we learned that for condition number 1, y raised to the power n must not be multiplied by any other thing. It must stand alone. So this is not a condition. The condition that we were looking for is not here. So this is also a linear differential equation. So we will write here linear differential equation. So we move on to the sixth question. We have equation here, y d square y over dx squared minus 2xy y squared. So when we look at this, this is not in the condition, it doesn't qualify. But when we look at this, this qualifies. This is condition number 3. So we can go back and check. This is condition number 3, y term multiplying a derivative term. And that is what we have here. The derivative term is the second derivative multiplying a y. So this equation is a nonlinear differential equation. So we have here nonlinear differential equation. So the seventh question, we have here this, the fourth order, the fourth derivative instead, minus 3 d square y over dx square plus y equal to x square. When we look at this, y is standing alone. The power of y is 1. And in our condition, we learned that the power of y must be greater than 1. So it doesn't qualify to be a nonlinear differential equation. So this is a linear differential equation. This is a linear differential equation because of this condition. Power, y was standing alone, but power is equal to 1. So we have linear differential equation. For this to qualify to be nonlinear, the power should be greater than 1. And then finally, this is the simplest. Any differential equation containing a square root is a nonlinear differential equation. So the last one, we have nonlinear differential equation. So this is my way of teaching you how to classify a differential equation into linearity and non-linearity. So from henceforth, I know that anytime you come across a differential equation, you would be able to classify it into linearity and non-linearity. So this video, I hope it has been helpful. Please subscribe to this channel. My name is Daniel, and I'll see you in my next video.